Join us today, but our very own Elizabeth Christensen has agreed to step into the breach in a pinch, as it were, and talk to us about being a spatial DBA in a pinch. And this is not a trivial question because pretty much a huge portion of people who get access to Postgres also suddenly find themselves gifted the role of DBA. Woe to those who introduce Postgres into their offices. Everyone will be very happy with the Postgres, but someone will end up carrying the mantle of the DBA, and they need to know what to do in a pinch. So Elizabeth is here to walk us through the basics.
Thank you. Let me know if you can.
I can see your desktop.
You see
and now I can see your presentation.
All right. Awesome. Well, thank you. Yeah. So, Chris Wade couldn't be here today. So I'm offering a talk that I just did at FOSS4G in Baltimore. So this is spatial DBA in a pinch, given in a pinch, because I apparently like to do things in a pinch. I'm going to turn off this closed captioning because it's a little distracting for me. All right. Just a little bit about me. I love Postgres. I love PostGIS. I work at Crunchy Data with Paul and Martin and all these amazing spatial people. I do a lot of Postgres education with our blog and our awesome tutorial site. If you haven't checked that out, we have tutorials that run in Postgres in a web browser. And I enjoy doing lots of Postgres education stuff. I also volunteer for the United States Postgres Association, PGUS. I do some education and events for them. And I also host a user group for Postgres in Kansas City. So if any of you are anywhere near me, I would love to have you come join us at a meeting. I'm on various social media platforms as SQL Liz, if you'd like to find me. So the original reason that I wrote this talk, and I've done other talks kind of similar to this, is sort of what Paul was saying, right? That lots of people are running databases without sort of formal DBA training, and the sort of even idea of having a DBA is sort of less and less popular now, right? But my first interaction with any, well, I guess with major database stuff was I was running a support team and a couple of people left, and I found myself running a SQL Server database. So I've also been gifted a database in the past. So if people are asking you about Postgres, or you're digging through the docs, or you're taking care of a database, if you're doing any of those things, this is kind of the place to start. So this is a pretty introductory talk. If you just joined us, we had a schedule change, and I'm filling in for the Chris Wade FEMA talk. Chris couldn't be here. If you are not interested in learning about being a DBA, you're welcome to take a walk or get an early lunch or whatever you would like. So traditional DBA roles, just at a super high level, right, are, creating databases, making sure those databases are available to the applications, the reporting servers, the users that need them, putting security protocols in place to make sure that, not just anybody can get to the database. Making sure that there's backups and disaster plans that sort of align with your business and kind of what things are needed, handling all the user permissions, making sure that things are fast and performant, and then obviously keeping up with versions and maintenance. I'm going to cover all of these at kind of a high level and just give a really quick introduction and kind of the major things you need to know for each of these topics. So in terms of hosting and provisioning Postgres and PostGIS, there's a lot of ways to get it, right? There's a lot of services available now and ways that you can deploy open source software. If you're deploying this locally and you have a Mac, the easiest way to get yourself PostGIS is through the Postgres.app. That'll just install everything together for you and you don't have to compile anything. If you are running a different operating system and you want to compile things yourself, you can do that. And then lots of people, kind of like what Bonnie was talking about, and lots of other people use different containers. Postgres does run really well in Kubernetes. There's several providers of Kubernetes operators. Crunchy Data has an operator as well. And then for folks that are kind of in the sort of managed world where you're sort of offloading lots of the keys to other people, Amazon RDS and Google Cloud SQL and Azure Postgres. Crunchy has a managed Postgres service called Crunchy Bridge that's sort of very similar to all of those, and then also multi-cloud. And if you're sort of thinking about what these things are, right? What is a self-managed database? What's a fully managed database? There's a lot of benefits and sort of trade-offs to either one, right? And it kind of depends on what your priorities are. So, a self-managed database is going to have a lot more control, right? You'll be able to SSH into the machine. You can do anything you want to it. But that means you're compiling and installing lots of software. And if you've seen kind of the version maps between Postgres and PostGIS, aligning all of those things is not a small job. And then if you're sort of looking at fully managed, you're going to outsource a lot of that work, right? All of the PostGIS, the Postgres, all of the extensions that are allowed have already been compiled and they already work together. They've already been tested. Typically fully managed is going to have, backups built in, lots of automation built into getting you on a new version of PostGIS, getting you on a new version of Postgres. If you want a slightly bigger machine with more memory, lots of that stuff is going to be right at your fingertips. And then sort of in exchange for all of those niceties, you do kind of let go of a little bit of the control and sort of let somebody else kind of manage that. So just a high level security overview. Obviously, if you've got some kind of server that you've either provisioned or you put it in the cloud, you'll need a firewall. You only obviously want your applications and users to be able to access your database. Checking firewall rules is super important if someone just handed you a database you've never seen before. And then, all of the managed cloud services have nice things like private networking and virtual private networking, where you can kind of create a private network between your application and your database, especially if you've got things, hosted in different places. You'll want to make sure you're on an SSL encrypted transaction so that when data is moving back and forth between your application and your database, it's secure. And then you'll want to give out roles to those applications and users who are using the data and sort of give them the least amount of permissions that they need to get their job done. So Postgres has a roles system that is kind of combined into, it used to be groups and roles, and now it's just roles under roles. So you can create a role like for your individual developers, and then you create individual roles inside of that group of roles. If you have just been given a Postgres database, you may have been given a Postgres super user. That is definitely a role you want to use sparingly and only when you're sort of editing some of the meta stuff inside the database, like creating roles and some of the bigger things for the actual machine itself. Your application and any end users or any reporting stuff, those should all have their own individual roles so that they're not able to change Postgres settings or overwrite anything special. One thing that is helpful for setting up roles is creating a statement timeout for each thing that you've got. So you can, in Postgres, have an application that runs a really long query or some kind of really long process that will sort of eat up all of your memory and make it difficult for other transactions to happen. So setting a statement timeout per application or per user can be a really smart idea. We usually tell people, a minute or 2 minutes. If you've run something for 2 minutes, you're probably not getting it. And then this sort of eliminates the chance that you've had, some report accidentally running for, 10 hours. When you are kind of picking up a database that you've never seen before, or kind of getting involved for the first time, taking care of what's going on with the backups is super important. So where are the backups is something you should try to find if you're, hosting locally. That'll be obviously something on that local machine. And then if you're using a managed service, knowing where those backups are and how to get to them is important. Postgres has a couple different levels of backups. There's a PG dump, which is not really a real backup. It's more like a way to pull all of your data if you needed to restore it or move it somewhere. If you have a small database and you automate a PG dump, that could be a backup, but it's generally not considered like a full production ready backup tool. Postgres has like a base backup that sort of takes that Postgres wall and creates a backup system for it. And then if you really want like a real backup system for Postgres, you're going to want to use PG Backrest. And that's kind of a system that you set up that'll have a full, either daily or every couple of days, a full backup, and then we'll increment your backup so that you can get a point in time recovery and sort of roll back to different points in time. If you're getting a managed service like through Crunchy Bridge or one of the other managed service providers, typically Backrest would be included with that, and then you would be able to create a point in time recovery. Some of the managed services call that point in time recovery a fork, if you've heard of that. And so you're also going to want to make sure you have some kind of database monitoring, right? And in the open source server world, there are hundreds of ways to monitor anything. The high level is that you'll want to kind of know what's going on with disk space. You'll want to know that your database is operational. Peeking at CPU is good, and knowing what's going on with your IOPS is also really good. Some providers, like if you're using a managed service provider like Crunchy Bridge, will kind of include a bunch of this stuff. And then, a lot of people sort of have third-party tools that they work with too. We work with a lot of clients that use something like Datadog. That'll run an agent inside your database and then export all of your metrics out. PG Analyze is another Postgres specific software as a service for Postgres that's really nice and does a lot of like query analysis and sort of performance stuff. And then if you're using, a database with a front end application, there's some nice like application performance monitoring tools like Scout APM and things like that will kind of give you a bigger picture of your full application stack and its performance. There's quite a few open source tools too. So if you're rolling your own and you don't want to work with a third party, we support a project called PG Monitor at Crunchy Data. That's really good. And it's based on Grafana. And then there's PG Watch 2, which I've used too, which is pretty easy to set up. You'll probably also want to know how to get at your Postgres logs. It sort of depends on how you've got your access set up. If you're using a managed service, typically you won't be able to tail all your logs. You'll have to send those to some kind of third party. Some of the third parties I mentioned will also sort of ingest your logs. So like PG Analyze and Datadog will let you send your logs there, and then kind of as the part of the bigger performance monitoring stuff, you can look at your logs. If you're self-hosting, you can just access your log file directly. There's a popular tool that you can run with Postgres called PG Badger that does a lot of sort of fancy stuff by taking your logs and kind of helping you output and make sense of it. And when you're setting up logs, you can tell Postgres, I have some sample code here for, how long of a statement do I want to log? Do I want to log temp files? Obviously, you don't want to log every single thing that's happening in your database because you'll fill up your server with logs. So kind of being smart about, how long of a statement you want to log, and do you want to log everything or just errors? So thinking through those things when you're setting up logging is a good idea. Postgres has a lot of statistics tables inside of it to sort of let you know what's going on. And that's kind of one of the cool things about Postgres is you can literally use Postgres to learn about Postgres. You can write SQL queries against things like the stat activity table and the stat statements table to just find out what's going on inside your database. So if things aren't working right, or you want to know what's happening right now, that stuff's all available, and you can connect to your database and write a query and find out what's going on. So if you are managing a database with spatial data, this kind of data is typically super memory intensive. I'm going to talk in the next couple slides about memory and some things that you can just kind of keep in the back of your mind in terms of memory tuning. But you will definitely want to think about memory, make sure that your system has enough working memory, and then think about potentially setting memory per session and per role. So Postgres has a lot of per session settings and per role settings that are really helpful. So if you need more memory to run a particular a particular import, or you're going to union a bunch of data or something, you can kind of get yourself extra memory and stuff like that. So one of the things that I find really helpful when talking about memory in Postgres comes out of a blog post that I wrote with my husband, David Christensen. It's on the Crunchy blog, and it's called Data Flow in Postgres. So, Postgres has a lot of layers to how it gets data to you. So if, a query is coming in from an application or a reporting server, that's going to go first then to, if you have a connection pooler in place, and then each individual piece that goes and gets data from Postgres is going to connect to what's called this individual client backend. And so Postgres sort of has layers to the memory, right? So at the bottom, you've got sort of the physical disk storage, the on disk cache, and then sort of above it, you've got kind of a memory layer, right? Like a cache layer. And then, at the top of that memory level, you've got a shared buffers, which is sort of data that's running in memory in Postgres's memory that's just kind of ready, right? So you don't have to go down to the underlying disk to get the data. So when you're talking about IOPS and Postgres, IOPS are whenever you write data all the way down to the physical storage layer, or whenever you read data from the underlying disk. So you can sort of reduce your IOPS and make things a lot faster by keeping more data in shared buffers. So typically, this is sort of a rough guide for how to allocate your Postgres memory. So, you would use about a quarter of whatever memory you've got on your machine for that shared buffers, and then you'd use another quarter of it for working memory, and then half of it for your file system cache. So when you're kind of tuning, you'll hear a lot of people talk about tuning, and there's some tools and things available if you kind of go looking on the internet for this. This is kind of general guide, but if you've got an 8 GB production machine, your shared buffers are going to be about 2 gigs. Generally, the shared buffers that Postgres gives you is lower than this, and it's too low. Working memory is the individual memory that each individual client backend gets. So when we were talking a couple slides ago about how those individual pieces get to shared buffers, each individual connection uses working memory, and Postgres has a default for that, which is 4 megs. Typically that's too low, and so you would divide that out about amongst the connections that you have. And there's some tools online if you need help kind of figuring out what that math is. The maintenance work memory is memory that Postgres uses internally to do things like vacuum and create indexes. This comes with a default out of the box that's typically also too low, and you can kind of tune that and change it. Do a little research about that before you change all this stuff. I want to talk a little bit about connections. So when a couple slides back, we're looking at sort of that data flow and how things go in and out of Postgres. If you just use Postgres out of the box, each individual connection that comes, from your application or from a user uses a connection. Postgres has a max connection setting that's 100. And if your application opens up a connection and it asks for some data, typically it'll leave that open, right? So it'll create an idle connection. And if you're scaling out an application across a couple different web servers or maybe a half a dozen web servers that are all going to be talking to Postgres, you kind of get into a situation where you end up with lots and lots of connections that are open and a lot of them are idle. And so they're all kind of using up some of that precious memory. So putting a connection pooler in place to sort of manage those idle connections for you helps sort of things be more memory efficient for Postgres. The PG Bouncer tool is sort of the standard for that. There's a couple other connection poolers, but we use PG Bouncer all the time, and it's very effective and easy to set up. PG Stat Statements is an extension that lets you track query statistics. It'll create a table for you, and then you can just write queries against that table and ask sort of, which queries are taking a long time, which queries are really slow. I think the sample query you have on the screen is just what are the 10 longest running queries. And just sort of talking a little bit more about performance and under the hood stuff is indexing. I know lots of the spatial people are super familiar with indexing. It's almost impossible to do anything with a spatial database without it. In the application development communities, that it's a little different. Like if you're just writing like Python, those people typically do not use as much indexing as the spatial communities. So indexing is obviously just a way to group data together so that the database can find it a lot faster. If you're doing spatial stuff, you're probably going to be using this gist index or the SP gist index. And that's almost a must-have for any geometry columns in your data. If you're doing other things with your database, like text and JSON and stuff, take a look at the B-tree and Brent indexes. They're super helpful too, especially for doing text searches and things like that. If you want to know if your indexes are being used in Postgres, you need to use Postgres's explain plan. So Postgres exposes query details for you. You basically just give Postgres the query and the phrase explain or explain analyze, and it will output the query for you and give you a bunch of details about it. Auto explain will do explain for you, and it will log your explain plans for you. It's pretty memory intensive, so is generally not super recommended, or it's not recommended to run for a long time on a production database. Here's an example of an explain plan. When I was getting ready to go to Baltimore, I worked on a little Baltimore roads database. And so here's an explain plan for a query where I just looked for all of the road data like in the downtown neighborhood. And so I put explain before my select statement, and then it just outputs, okay, it took me this much planning time, and then it took me about 600 milliseconds to execute the query. I added an index, just a simple just index to that geometry column. I ran the same explain plan, and that query ran in 1 millisecond. So indexing is not just like, oh, it makes it a little bit faster, it makes it 10% faster. It's orders of magnitude faster. So not not optional. And I'm sure a lot of you guys already know this, so I'm probably preaching to the choir about indexing. But yeah, and another sort of kind of high level thing to think about if you're kind of looking at data and things are slow and you kind of want to optimize some of what's going on in your data set is to just use smaller sets of data, right? So instead of querying for everything, find things that are, within a certain area or overlap a certain area instead of querying for everything. Adding some of these functions, especially if you have an application in front of it, is going to make things a lot faster for your users. So yeah, if you are sort of if you're being a DBA in a pinch and you need more help, there's tons of great stuff in out there in the community. The Postgres Slack is really helpful. They have a Liberia kind of IRC chat too. The Planet Postgres blog list is awesome. The Postgres has a mailing list, I know, and Paul tends to answer quite a bit of those. I see some of those questions and answers. Crunchy has a really nice newsletter that has tons of educational Postgres and PostGIS content. And then we have a cool playground if you kind of want to mess around and see some of the stuff I talked about is actually in our playground in little sample databases, and those are databases that run in a web browser, so you don't have to install anything. You can just kind of mess around and throw some queries against a database. So yeah, that is
right.
what I have prepared.
Thank you so much, Elizabeth. So I was wondering, like, I can't help it. It's just the way I operate. I just use the Postgres user all the time. And then I give the Postgres user login to everyone so they can use it all the time. Because that way everyone has access. Like, what are the downsides of just having everyone use the Postgres user? What's the worst that could happen?
I mean, the worst that could happen is that, people take down stuff or delete data, or, like you can run an alter system with the Postgres user, which will change your memory settings. I mean, there's a lot of stuff you can change with pretty simple queries for underlying Postgres settings. I mean, we've all had a cat delete a config file, no? I mean, I mean, like.
Yeah. Okay, so I mean, I was going to add, like, what's the biggest DBA pitfall? What's the most terrible thing you've seen done as a DBA? And it might be something you did yourself.
I mean, like the traditional drop tables. I mean, I've dropped a table, like,
Dropped a production. Fortunately, in my time, I've never
I
actually
have dropped
dropped a production table.
Yeah.
Frightening.
Oh no. Yeah. And this was like back in the old days when there was not point in time recovery, and you were like, some guy had a disk, had a tape. We had all of our databases backed up on tape. I'm really old, so young people don't pay attention, but yeah, I mean, like when you have to get stuff off of tape, you have messed up.
And I guess, I mean, the worst part of dropping in the production table is like you have to tell everyone, stop using the database, because yeah, everything you add, we're going to get rid of because we're going to do a restore. Brutal. Okay. Thank you very much for stepping into the breach in a pinch and telling us about DBA stuff. I see.